young minds meet tomorrow's tech.
Pascal's mighty force, exploring pressure in fluids. Hello, young scientists. I'm Professor Pascal, and today we're going to explore one of the coolest concepts in fluid mechanics, Pascal's principle. Have you ever wondered why a water balloon bulges when you squeeze it? Well, that's Pascal's principle in action. Let's take a closer look. The experiment with the water balloon. Here's the experiment. Watch closely as Noah squeezes one side of the balloon. What happens to the water? Just like magic. When Noah presses one side, the water bulges out on the other side. That's because of Pascal's principle. It states that when pressure is applied to a fluid in a closed container, the pressure spreads evenly in all directions. How Pascal's principle works. So when Noah presses the balloon, the pressure from his hand spreads throughout the water, pushing it out in all directions. The pressure doesn't just stay on the side where Noah is pressing, it moves everywhere in the balloon. That's Pascal's principle at work. The pressure is transmitted equally in all directions, which is why the water bulges out in places where there's no pressure being applied. This is the same principle that makes hydraulic systems work. Real-life applications of Pascal's principle. Pascal's principle is used in many real-life systems, like hydraulic lifts, which are used to lift heavy objects like cars. In a hydraulic system, applying pressure to a small area can create a much larger force on a bigger area. By applying pressure to a small area, we can lift something really heavy because the pressure gets transmitted evenly, making lifting easier. It's all thanks to Pascal's principle. Summary and key takeaways. So, to sum it up, Pascal's principle tells us that when we apply pressure to a fluid in a closed container, that pressure is transmitted equally in all directions. This is why squeezing one side of a water balloon makes the water move everywhere. And it's also how hydraulic systems work to lift heavy objects. Next time you see a hydraulic lift or even just a water balloon, you'll know exactly how Pascal's principle makes things work. Keep experimenting and exploring the world of fluids, and I'll see you next time for more exciting science with Professor Pascal. See you soon, young scientists, and remember, pressure is a mighty force when it's used the right way.
Brought to you by Meta Robotics Education.